In this video, we are going to do a pre-calc review question for a calc class. And so we're asked to find the domain, range, and inverse of this rational function. So it's rational because I have a variable in the denominator, which leads us to have some domain issues, which then has a tendency to have some range issues. So let's go through the math on this. So domain-wise, what we're looking for is where do we have an issue with the denominator. When the denominator cannot equal zero, so we're going to try to figure out when it does equal zero, which basically means we are saying that this denominator cannot equal zero. So we're going to find the value when it does equal it and then kick it out. So if we add 6 over to it, we're looking at 3x is going to equal 6. And then we'll divide by 3. So x is going to equal 2. So actually, that is our problem. So x cannot equal 2. So our domain is going to go from negative infinity to 2, and then from 2 to infinity. All right, and then the range is a little easier if we do a visual to it, but in general, we'll talk about the algebra to it, is we're going to have a horizontal asymptote on this one because we have the powers that are moving at the same rate, and so we're going to focus on the coefficients. So we're going to have a horizontal asymptote at y equals these coefficients. So 4/3. And so that's actually the y value that we're not going to get. So that's going to end up being our range. And this is going to create a vertical asymptote. So we're going to do a graph of this just to kind of help visualize what it is that we got going on. So our range is going to be from negative infinity to 4/3, and then 4/3 to infinity. Okay, so visually, here's kind of what we got going on. We have this rational function, and this rational function has a vertical asymptote at 2, and we have a horizontal asymptote at 4/3. Some other pieces that are going to help us out is the fact that the numerator, if you set this one equal to 0, that's going to get you an x-intercept. So if we set this equal to 0 and solved it, we would add 2 and then divide by 4, which would get us a 1/2. So we'd have an x-intercept at 1/2, which tells us that this chunk of our rational is going to be in this section. And then since we don't have a second x-intercept, it can't be in this section, it has to be above. So now we can kind of see that this x value gets kicked out because it's a vertical asymptote, so we got to kick it out of the domain. And then horizontal asymptote, the graph level is off at 4/3 but never crosses it. So we're going to have a range issue at 4/3, so we kick it out. The last part of this is finding the inverse. So the inverse is we're going to take our original equation. It's 2, 3x minus 6. And to do the inverse, we're going to switch the x's and y's. We always do that on any inverse. So 3y minus 6. And then we're going to try to isolate the y, get y by itself. So first thing I'm going to do is I'm going to clear out my fraction. So I'm going to multiply the 3y minus 6 over to the other side. 3y minus 6. So it'll clear out the fraction here. And we're going to distribute, so that way we don't have parentheses, so we can move things around. So if I distribute that, we're looking at a 3x y minus 6x equals the 4y minus 2. And then let's get y's by on the same side, and anything without a y on the other side. So this piece we would be subtracting over to this side, and this negative 6x will be adding it over to the other side. So if we shift the 4y over, we would have a minus 4y equals a 6x minus 2. All right. And then ideally, we'd have like terms that we can combine, and then we don't have to worry about anything with our y's, but we don't have that situation. But the reason that we put the y's on the same side is because now we have y's in common, which allows us to divide the y out. So if I divide a y out of these two pieces, I'm going to be left with a 3x minus 4. And that just took two y's and condensed them down to 1. And then we can divide this 3x minus 4 over to the other side. And now we've gotten the y isolated. And then we'll kind of pretty up our answer. This is an inverse of this original function. So I'm going to rewrite my final answer as a 6x minus 2, 3x minus 4. Now, one last thing I want to do is here's our domain, here's our range, and here's our inverse. I want to make sure we're right. And it's a very quick, easy way to do this is we're going to check the visual on this. But rather than me graphing this again, we're going to shift over to Desmos and kind of validate, how do we know this thing is right? So we're going to shift over Desmos. And so here's your original graph. And so here's our vertical asymptote. So this is the graph that I have turned on. We have our vertical asymptote at 2, and we have our leveling off at 4/3. And then this is what we got for an inverse, which I don't know, it's kind of hard to tell. So what we can do instead is if we turn on the idea visually that if you know you have an inverse, these things should be reflections of each other over a 45, over the y equals x. So how do we validate that? We can take some points and kind of see. So this 5, 2 is on our original graph. An inverse of it would be 2, 5, which is very nicely on the inverse graph. So we do that with multiple points. Another thing that I'm looking for is if these original graphs intersect anywhere, which they do, they will always intersect on that line of reflection. That's another point that we're looking for. If they intersected over here, something was wrong. So everything looks great. So that is our original. That's our inverse. We've done the domains and ranges, and we have everything done. Thanks for watching. Hope that helped.